So we have this problem on my math lab that discusses this property in math about the greatest common factor of two numbers and a related Fibonacci number. It really isn't a lot to do with this problem, but the math notation can be heavy enough that it's hard to understand what's even being asked of you. So first, I want to start out by addressing the f sub m, f sub n. Those are indicating your Fibonacci numbers. So I've made a chart here of the Fibonacci numbers up to f sub 14. And this isn't a chart that I have memorized, I'm just generating it. All you have to know is that the first two are 1, and then after that, the next one comes from adding those. So 2 is 1 plus 1. 3 is 1 plus 2. 5 is 2 plus 3, and so on. So I've generated all these out up to F14. And the reason why I decided to go up to F14 is because up here in the problem, when I look at the m's and m's that they're asking me to look at, the largest one of those is 14. So I needed to know up to F14. Now, what this theorem or property is actually saying is if I take any two numbers, for example, we'll just start with 10 and 4 and determine their GCF. In this case, the GCF of 10 and 4 is 2 because it's the biggest number that divides into both of those. So that's really all the math that you're doing in this problem is determining greatest common factors. So the GCF of 10 and 4 is 2, and now what we're going to do is look at all of the related Fibonacci numbers for those. In other words, we're going to look at f sub 10, f sub 4, and f sub 2. So we're going to take all the numbers that they asked us about and look at their corresponding Fibonacci numbers. So f sub 10, if we look it up in the chart, is a 55. F sub 4 in the chart is a 3. And then f sub 2 is a 1. So then the statement becomes the GCF of 55 and 3 is 1, and that's true because there's not really any numbers that divide into 55 and 3 except for 1. So that's a true statement. Now let's look at our options that were given up here to understand what they're asking us to do. Okay, so first of all, there's no difference between the first statement and the second statement for the first part. So that part, you really have no options. The options come with the last part of the sentence. So here in the second part of the sentence, they're saying the GCF of f sub 10 equal to 55 and f sub 4 equal to 3. And that differs from the second sentence of f sub 10 equal to 21 and f sub 4 equal to 55. Well, f sub 10 is 55. Let me do that in yellow so the colors correspond. F sub 10 is 55 and f sub 4 is 3. So we don't even really have to figure out the GCF of these Fibonacci numbers. They didn't give us an option on that. The f sub 2 matched in both problems. What we really need to verify is that the Fibonacci numbers that they're giving us in the two options, which one are the correct Fibonacci numbers? Well, f sub 10 is 55. And so that means that A has to be the correct statement. So you're not really doing a lot of math with this as much as verifying that they're representing the Fibonacci numbers correctly. You don't have to prove the statement that they're making. You have to select which one is the accurate statement. Alright, I want to go through this for part B and C. I don't have those options listed here because I took a picture of the one with just part A up. But let's go ahead and look at part B. We can kind of predict how it plays out, and then we'll look at part C. So for B, we're looking for the GCF of 12 and 6, and that's 6. So then we just translate those into Fibonacci numbers. So we're going to look at the 12th Fibonacci number and the 6th Fibonacci number. The 12th Fibonacci number, looking it up in my chart here, is 144. And my 6th Fibonacci number is 8. Now the question is it, and these match, so then that would be another 8 there. So is the GCF of 144 and 8, is that 8? And it is, but again, we don't even, the way they're giving us these options, we don't even need to verify that. What we need to verify is that they're listing the correct Fibonacci number for F12 and the correct Fibonacci number for F6. They're not really giving us a variation on the GCF piece of that. Alright, let's go ahead and go through the third option here, part C, and see what that looks like. So our numbers are 14 and 6. The GCF of 14 and 6 is 2, but really that's not part of what's being an option here. What we need to look at here is the Fibonacci number of 14 and the Fibonacci number of 6 and verify that those are correct in the rest of the statement. So the GCF of 377 and 8 would equal a 1. Let me write that out like I have been before. So F sub 14 is 377, F sub 6 is 8, and F sub 2 is 1. So what this property tells us is that the GCF of 377 and 8 is 1. And kind of the beauty of this property is I don't have to figure out what the GCF of these two numbers is. I just need to figure out, if I know their Fibonacci numbers, I just need to figure out the GCF of their relative position in the Fibonacci sequence. That's the idea. So the notation's kind of rough, but if you can get past the notation, what you'll start to see is all they're asking you to do is verify the Fibonacci number's position in the sequence. I hope this helps. Go ahead and give it a try. Let me know if you need further clarity on it.